Hey guys, we are checking out a little more of the applications of the unit circle, working actually with some equations like this. So let's get started. We want to take sine of theta and find two angles that give you negative 0.4 in this range between 0 and 2 pi. So we've done this before, kind of theoretically thinking about the unit circle and exact locations. This isn't one of those exact locations. So if you crush it through your calculator, take the inverse sine of negative 0.4, I got that theta should be negative 0.412, something like that. And that's fine, except our angle can't be negative. It's got to be between 0 and 2 pi. So negative 0.4 would be down here someplace, right? Like it would be this angle. And we're talking about the sine, right? So the sine is the y value. So we want our point to be this far down, right? We want it to be negative 0.4 down. Well, there's another spot that occurs, and that's straight across from it here. So this spot would work too. Yeah. So you could think of it like this. This angle should be this same angle, right? This should be 0.412, and this should be 0.412. So I think one of your points, this point, should be pi, right? Pi plus our angle, right? Plus 0.412. And this point should be 2 pi minus the angle, right, going backwards. So then 2 pi minus the 0.412. And you can run that through your calculator and find a decimal equivalent for it. I think it should be hiding behind this blue guy here. So here's the kind of formal solutions for it, but here's the pi plus 0.412 and 2 pi minus 0.412. You should get 0.355 and 5.8. Try that out. Make sure you can get those. All right. We want to be able to also do this with exact values. So we want to find all angles in a full rotation so that the cosine is a half. Well, the cosine is half. It means it's positive, and this comes from one of our 30, 60, 90 right triangles. The cosine is the x value, which means that if we use this one like that, this longest side is x, and that would be the root 3 over 2, and that's not what we want, right? So we want the x value to be the shorter of the two, right? The half value. So it's going to be either this triangle, right, where this value is a half, or this triangle where this x value also is a half, right? So these points here and here have this property that the cosine is a half. So we got to figure out what those points are. Well, one of them, if we are comfortable with the unit circle, should be pi thirds, right? That's a 60-degree triangle. The other one's going to be pi thirds down, right? You could call it a negative pi thirds, except we can't leave it like that because we want our angle to be positive, right? So it's got to be somewhere in the unit circle. So you could call it maybe here's 0. If we went all the way around, it would be 2 pi, right? And so this point should be 2 pi minus pi thirds, right? Or if you're comfortable with naming this area where this is, you know that 2 pi really is 6 pi thirds. So this should be 5 pi thirds. Right, so this is back one. If you can do that subtraction, should be 5 pi thirds. Let's try it out. There we go. Bing. All right. Last but certainly not least, we want to also be able to work some equations that are a little bit uglier. So we want to show without a calculator that this mess equals negative 6. All right. Well, we can do that. Let's just find some exact values for these pieces. So this is 8 times sine of pi thirds. Well, pi thirds should be here. Right, that's pi thirds, and the sine of pi thirds is the vertical component. So the vertical component here should be root 3 over 2. Right, so this should be root 3 over 2. It's positive. That's great. Let's look at cosine of 5 pi sixths. 5 pi sixths is going to be, well, this is like 1 pi sixth, right? 2 pi sixths, 3 pi sixths, 4 pi sixths. Here's 5 pi sixths. Yeah, here's 5 pi sixths. And the cosine is the horizontal component of it. It's the x value, right? So it's this piece, and that's root 3 over 2. But since it's going backwards, it's negative root 3 over 2. So times negative root 3 over 2. Great. If we multiply all this together, you get 8 times, let's call it 8 over 1, times root 3 times negative root 3 is just negative 3, and the 2 times 2 is 4. And so you get, these cancel out. You get 2 times negative 3, you get negative 6. Let's try that out. Yeah, there you go, negative 6. Sweet. So using the exact values, often you can clean things up without a calculator. I'm sure if you threw in your calculator too, you could get negative 6 out of it. Just be careful with your parentheses. Cool, that's it. We'll work a few of these in class. Bye.